Hi to all. In this video, I am going to explain you what is meant by flip-flop and what are the types of flip-flop. First of all, before going to see about what are the types of flip-flop, I want to explain what is meant by flip-flop. Flip-flop is a device which is used to store one bit of information, either it should be 1 or 0. So it has the capacity to store one bit of information. Latch is also a 1-bit memory storable device. The main difference between latch and flip-flop is a latch is not triggered by using clock, whereas flip-flop can be triggered by using clock. So this is the major difference between latch and flip-flop. In latch, we only bother about the inputs. We doesn't consider the clock pulse because clock pulse trigger input is not available in latch, whereas in flip-flop it can consider both the inputs as well as the clock pulse. So there are 4 types of flip-flop available. The first one is SR flip-flop, and second one is JK flip-flop, and third one is T flip-flop, and last one is D, that is delay flip-flop. In this video I am going to explain you what is meant by SR flip-flop and JK flip-flop. So this is the SR flip-flop, and this is the general block diagram of SR flip-flop. And in SR flip-flop we are going to give two input S and R. You are supposed to get two outputs Q of T and Q of T plus 1. And Q of T plus 1 is nothing but the next state output, and Q of 2 is nothing but the present state output for the given input. So whenever you are giving some input, the Q of T is nothing but the present state output of this given input, and Q of T plus 1 is nothing but the next state output. And here there is a circuit diagram. This is nothing but a latch because there is no clock pulse given in this circuit. That's why it is called as SR latch. Where here in this circuit you are supposed to give a clock signal as an input, and this is the proper circuit diagram of SR flip-flop. So I am giving S as an input and R as an input and clock pulse as an input. Whenever clock pulse going to the edge trigger or level trigger, the output must be changed. Okay, here Q of T, I already told you, this is a present state output for the given input combination, and Q of T plus 1 is the next state output. So before going to write the truth table for this SR flip-flop, I am going to explain the operation of the circuit diagram. So S is nothing but set and R is nothing but reset. The first input combination is here. I am using two input, one is S and R. Therefore, we are supposed to get 4 input combination. One is 0, 0, 0, 1, 1, 0 and 1, 1. So the first input combination 0, 0 means Q of T may be either 0 or 1. In Q of T plus 1 there is no change. Whatever may be the Q of T value, that should be obtained in Q of T plus 1. So whenever S is 0 and R is 0, Q of T plus 1 following the Q of T. It should be 0 or 1. The same thing should be obtained here also. The next combination input is 0 or 1. For 0 or 1, 1 is nothing but a reset state. Set state is 0. So for this combination, whenever Q of T present state is 0 means Q of T plus 1 is 0. Whenever Q of T for this 0, 1 combination, it should be 1 means, whereas Q of T plus 1 is 0. This is nothing but restate. From this you are supposed to conclude that for this 0, 1 combination, whatever may be the Q of T value, either it should be 0 or 1, you are supposed to get 0 and 0 at the Q of T plus 1. So next state should be 0 for this restate condition. That's why it is called as restate. And third one is 1, 0. That is S is 1 and R is 0. In this condition, Q of T value is 0. Then Q of T plus 1 is 1. In this combination, if Q of T value is 1 means Q of T plus 1 is 1. Whatever may be the output of Q of T plus 1, Q of T plus 1, the next state is 1, 1. So it is called a set state. For each set state it is 0. It doesn't consider the Q of T. For set state it doesn't consider Q of T. So it should be set to 1, 1. Whenever S is equal to 1, Q of T plus 1 is 1, 1. And last case is 1 and 1 input combination. If Q of T plus 1 is, Q of T is 0 and Q of T is 1, it is an undetermined output. Either it should be 0 or 1, otherwise it should be 0 or 1 for the obtained Q of T value. So from this working principle, we are going to write the truth table. I already told you, whenever S is 0, R is 0, there is no change. Q of t plus 1 follow Q of t, both the things are equal. Whenever 0 1, restate is 1. So in this reset state, Q of t plus 1, it is equal to 0. It doesn't consider Q of t, either it should be 0 or 1. Simply it can set to 0. Whenever S is 1 or is 0, set state, Q of t plus 1, it is equal to 1. Whatever may be the Q of t value, it should be 0 or 1, it should be set to 1. For 1 1, it is nothing but undetermined. So this is the characteristics table of the SR flip-flop. So whenever S is 0 or is 0, Q of t plus 1 follow of Q of t. Whenever 0 or 1, it is reset state, so it becomes 0. Whenever 1 or 0, Q of t plus 1, it is equal to 1. Whenever 1 1, it should be undetermined. So next we are going to form the state equation for SR flip-flop. So before going to frame the state equation from this characteristic table, I am going to apply this characteristic table values in the K-map. Okay, so this is a two variable K-map. From this K-map, it is possible for you to find out what is the state equation or final equation of Q of t plus 1. So this is a two variable K-map. Q of t 0, otherwise it is 1. For SR, I already told you there is a 4 input combination 0 0, 0 1, 1 1 and 1 0. Here Q of t is 0, R is 0 0 and Q of t plus 1 is 0. There is no change. Q of t is 0. It is a reset state, so automatically it goes to 0. This is set state, so automatically it goes to 1. Whenever the present state output is 0, it can set to 1. This is 1 1, so it is undetermined. And next to this thing is Q of t is 1 for this given input combination 0 0, 0 1, 1 0, 1 1. So 0 0, no change. The 1 repeat here also. This is the reset state, so it can go to 0. This is set state, so it can set to 1. For 1 1 input combination, either it should be 0 or 1, it should be undetermined. So from this, we are supposed to put the values in this K-map and find out the state equation. So here 0, 0, 0, the value is 0. So it doesn't put anything here. Next is 0, 0, 1, 0, 0, 1. So it doesn't put anything because the value is 0. Here 0, 1, 0. So 0, 1, 0, I put the value 1, Q of t plus 1. And next, because I am going to find out the Q of t plus 1, so I am putting the value 1. 0, 1, 1. I consider the cross also. So 0, 1, 1. That is Q of t is 0, S is 1, R is 1, S is 1, R is 1. I put cross. Similarly, here also, I am supposed to get 1, 1 cross. It doesn't consider this 0. So 1, 0, 0, I put 1. So 1, 0, 0, I put 1. And triple 1, I put cross. And 1, 1, 0, I put 1. So 1, 1, 0, I put 1. And 1, 1, 1, there is triple 1, I put cross. This is like a dice. If I fold the dice in the middle, otherwise I can fold the dice in this point. This things pair should be formed. So whenever these things form a quad, whenever all the rows and columns have the value 1 means, then it should be form a octal pair. So here there are 4 things present neighbor to each other, so it can form a quad. This one is parable to here, and this one is also pair to here also. So I am going to write an equation for this quad. So Q of t is 0 and SR is 1 1, and Q of t is 0 and SR is 1 0, and Q of t is 1 and SR is 1 1, and Q of t is 1 and SR is 1 0. From this I am going to find out the value. Here there is the values are different, 0 0 1 0. Here the values are same, so I put S here. Here the values are different, so I doesn't put anything. And for this pair I am going to write an equation. So 1 triple 1 0 0 1 1 0. I get an equation like this. This is Q of t, S and R 1 1. I get Q of t, and in this point I doesn't get anything, and here I am supposed to get R bar. So the final equation Q of t plus 1 is nothing but this 2 combination S plus R bar Q of t. So from this it is possible